still to validate things that aren't email addresses, but are data that are important to you. So we at least now have these building blocks. Now, besides the regular expressions themselves, it turns out there's other functions in Python's RE library for regular expressions. Among them is this function here, re.match, which is actually very similar to re.search, except you don't have to specify the caret symbol at the very beginning of your regex if you want to match expressions themselves. It turns out there's other functions in Python's RE library for regular expressions. Among them is this function here, re.match, which is actually very similar to re.search, except you don't have to specify the caret symbol at the very beginning of your regex if you want to match from the start of a string. re.match by design will automatically start matching from the start of the string for you. Similar in spirit is re.fullmatch, which does the same thing, but not only matches at the start of the string, but the end of the string, so that you too don't need to type in the caret symbol or the $ as well. But let's go ahead and transition back now to some actual code whereby we solve a different problem in spirit. Rather than just validate the user's input and make sure it looks the way we want, let's just assume that the users are not going to type in data exactly as we want, and so we're going to have to clean up their input. This happens so often when you're using like a Google form or Office 365 form or anything else to collect user input. No matter what your form question says, your users are not necessarily going to follow those directions. They might go ahead and type in something that's a little differently formatted than you might like. Now, you could certainly go through the results and download a CSV or open the Google spreadsheet or equivalent in Excel and just clean up all of the data manually. But if you've got lots of submissions, dozens, hundreds, thousands of rows in your data set, doing things manually might not be very fun. It might be much more effective to write code, as in Python, that can allow you to clean up that data and any future data as well. So let me propose that we go ahead here and close validate.py, and let's go ahead and create a new program altogether called format.py, the goal of which is to reformat the user's input in the format we expect. I'm going to go ahead and run code of format.py, and let's suppose that the data we're going to reformat is the user's name. So not email address, but name this time. And we're going to hope that they type in their name properly, like David Malin. But some users might be in the habit, for whatever reason, of typing their name backwards, if you will, with a comma, such as Malin, comma, David instead. Now, it's fine because both are clearly as readable to the human. But if you want to standardize how those names are stored in your system, perhaps a database or CSV file or something else, it would be nice to at least standardize or canonicalize the format in which you're storing your data, so that if you print out the user's name, it's always the same format, David Malin, and there's no commas or backwardsness to it. So let's go ahead and do something familiar. Let's go ahead and give myself a variable called name and set it equal to the return value of input, asking the user, as we've done many times, what's your name, question mark. I'm going to go ahead and proactively at least clean up some messiness, as we keep doing here, by just stripping off any leading or trailing white space, just in case the user accidentally hits the space bar. We don't want that ultimately in our data set. And now let me go ahead and do this, as we've done before. Let me just go ahead quickly and print out, just to make sure I'm off to the right start, hello, and then in curly braces, name. So making an F string to format hello, comma, name. Now, let me go ahead and clear my screen and run Python of format.py. Let me behave and type in my name as I normally would, David space Malin, enter. And I think the output looks pretty good. It looks as expected grammatically. Let me now go ahead, though, and play this game again, but this time maybe because I'm not thinking or I'm just in the habit of doing last name, comma, first, I do Malin, comma, David, and hit enter. All right, well, this now is weird. Even though the program is just spitting out exactly what I typed in, arguably this is not close to correct, at least grammatically. It should really say, hello, David Malin. Now, maybe I could have some if conditions and I could just reject the user's input if they type a comma or get their names backwards somehow. But that's going to be too little too late if the user has already submitted a form online and I already have the data, and now I need to go in and clean it up. And it's not going to be fun to go through manually in Google Spreadsheets or Apple Numbers or Microsoft Excel and manually fix a lot of people's names to get rid of the commas and move the first name before the last, as is conventional in the US. So let's do this. It could be a little fragile, but let's start to express ourselves a little programmatically here and ask this. If there is a comma in the person's name, which is Pythonic, I'm just asking the question, is this shorter string in this longer string? Then let me go ahead and do this. Let me go ahead and grab that name in the variable, split on not just the comma, but the space after, assuming the human typed in a space after their name. And let me go ahead and store the result of that splitting of Malin, comma, David into two variables. Let's do last, comma, first. Again, unpacking the sequence of values that comes back. Now, let me go ahead and reformat the name. So I'm going to forcibly change the user's name to be as I expect. So name is actually going to be this format string. First name, then last name, both in curly braces, but formatted together with a single space so that I'm overriding the user's input and updating my name variable accordingly. For the moment, to be clear, this program is interactive. Like the users, like me, are typing their name into the program. But imagine the data already is in a CSV file. It came in from some process like a Google form or something else online. You could imagine writing code similar to this, but that maybe goes and reads that file into memory first. Maybe it's a CSV via a CSV reader or dict reader, and then iterating over each of those names. But we'll keep it simple and just do one name at a time. But now what's kind of interesting here is if I go back to my terminal window and clear it and run Python of format.py and hit enter, I'm going to type in David space Malin as before, and I think we're still good. But I'm also going to go ahead and do this. Python of format.py, Malin, comma, David, with a space in between, crossing my fingers and hit enter, and voila. That now has been fixed. Such a simple thing, to be sure, but it is so commonly necessary to clean up users' input. Here we see at least one way to do so pretty easily. Now, to be fair, there's some problems here. And in fact, can someone imagine a scenario in which this code really doesn't fix the user's input? What could still go wrong even with this fix in my code? Any thoughts?
If they type in their name, comma, and then sign them.
Oh, and then something else. Yeah, so let me try this, for instance. Let me go ahead and run a program. And I am the only David Malin that I know. But suppose I were, let's say, junior, like this. And it's common in English, at least, to sometimes put a comma there. You don't necessarily need the comma. But I'm one of those people who uses a comma. That's now really, really broken. So I've broken some assumption there. And so that could certainly go wrong here. What else? Well, let me go ahead and run this again. And if I did Malin, comma, David, no space, because I'm being a little sloppy, I'm not paying attention, which is going to happen when you have lots of users ultimately. Well, this really broke now. Notice I have a value error, an actual exception. Why? Well, because split is supposed to be splitting the string into two strings by looking for the comma and a space. But if there is no comma and space, it can't split it into two things. And the fact that I have two variables on the left, but I'm only getting back one thing on the right, means that I can't do this code quite as this. So it's fragile, to be sure, but wouldn't it be nice if we could at least improve it? For instance, we now know some regular expression syntax. What if I at least wanted to make this space optional? Well, I could use my newfound regular expression syntax and put a question mark. Question mark means 0 or 1 of the things to the left. What's the thing to the left? It's literally a space. I don't even need parentheses if there's just one thing there. So that would be the start of a pattern that says I must have a comma, and then I may or may not have a space, 0 or 1 spaces thereafter. Unfortunately, the version of split that's built into the stir variable, as in this case, doesn't support regular expressions. If we want our regular expressions, we need to go use that library here. So let me go ahead and do this. Let me go in and leave this code as is, but go up to the top now and import RE to import the library for regular expressions. And now let me go ahead and start changing my approach here. I'm going to go ahead and do this. I'm going to use the same function called re.search, and I'm going to search for a pattern that I think will be last, comma, first. So let me use my newfound regular expression syntax and represent a pattern for something like Malin, comma, space, David. How can I do this? Well, inside of my quotes for re.search, I'm going to have something, so dot plus, I'm going to have something, so dot plus. Then I'm going to have a comma. Then I'm going to have a space. Then I'm going to have something dot plus. Now I'm going to preemptively refine this a little bit. I want this whole pattern to start matching at the beginning of the user's input, so I'm going to add the caret right away. And I want the end of the user's input to be matched as well, so that I'm literally expecting any character one or more times, then a comma, then a space, then any other character one or more times. And then that is it. And I'm going to pass in the name variable as before. Now, when we've used re.search in the past, we really used it just to answer a question. Does the user's input match the following pattern or not, true or false, effectively? But re.search is actually more powerful than that. You can actually get back more information, and you can do this. You can specify a variable and then an assignment operator and get back more precise answers to what has been found when searched for. But what is it you want to get back? Well, it turns out there's this other feature of regular expressions which allow you to use parentheses not just to group things together, but to capture them. It turns out when you specify parentheses in a regular expression, unbeknownst to us up until now, everything in the parentheses will be returned to you as a return value from the re.search function. It's going to allow you to extract specific amounts of information from the user's own input. You can reverse this process, too, by using the non-capturing version as well. You can use parentheses and then literally a question mark and a colon and then some other stuff, and that will say, don't bother capturing this. I just want to group things. But for now, we're going to use just the parentheses themselves. So how am I going to do this? Well, if I want to get back the user's last name and first name, I think what I want to capture is the dot plus here and the dot plus here. So I've deliberately surrounded in parentheses the dot plus, both to the left and the right of the comma, not because I'm grouping them together per se. I'm not adding a question mark. I'm not adding up another plus or a star. I'm using parentheses now for capturing purposes. Why? Well, I'm going to do this next. I'm going to still ask a Boolean question like, if there are matches, then do this. So if matches is not effectively false, like none, I do expect I've gotten back some matches. And watch what I can do now. I can do last, comma first, equals whatever matches in and get back all of the groups of matches. Then go ahead and update name just like before with a format string and do first and then last in curly braces as well. And then at the very bottom, just like before, print out, for instance, hello, comma, name. So the new code now is everything highlighted here. I'm using re.search to search for whether the user typed their name in last, comma, first format. But I am more powerfully using re.search to capture some of the user's input. What's going to get captured? Anything I surrounded in parentheses will be returned to me as return values. How do you get at those return values? You ask the variable to which you assigned them for all of the groups of parentheses that were captured. So let me go ahead and do this. Let me go ahead now and run Python of format.py, enter, and I'm going to type my name as usual. In this case, nothing happens with this if condition. Why? Because I did not type a comma, and so this search does not find a comma, so there are no matches. So we immediately just print out hello name. Nothing interesting or new there. But if I now go ahead and clear my screen and run Python of format.py and do Malin, comma, space David, enter, we've reformatted my name. Well, how did this work? Let me be a little more explicit now. It turns out I don't have to just say matches.groups. I can get specific groups back that I want. So let me change my code a little bit more. Let me go ahead now and just say this. Let's update name actually, let's do this. Let's say that the last name is going to be in the matches, but specifically group 1. The first name is going to be in the matches, but specifically group 2. Why 1 and 2? Because this is the first set of parentheses to the left of the comma. This is the second set of parentheses to the right of the comma. And based on the input, this would be the user's last name in this scenario, Malin. This would be the user's first name, David, in this scenario. That's why I'm using group 1 for the last name and group 2 for the first name. And now I'm going to go ahead and say name equals f string again, first and then last, done. And let me refine this one last step before we take questions. I don't really need these variables if I'm immediately using them. Let's just go ahead and tighten this up further, as we've done in the past for design's sake. If I want to make the name the concatenation of the person's first name and last name, let's just do this. Matches.group2 first plus a space plus matches.group1. So it's just up to me to know from left to right, this is group 1, this is group 2. So group 1 is last, group 2 is first. So if I want to flip them around and update the value of name, I can explicitly get group 2 first, concatenate using plus, a single space, and then concatenate on group 1. All right, that was a lot. Let me pause to see if there are questions. The key difference here is we're still using re.search the exact same way, but now I'm using its return value, not just to answer a question true or false, but to actually get back specific matches, anything I captured, so to speak, with parentheses.
Why is it here we're using 1 and 2 instead of 0 and 1?
A really good question.
Capturing the first.
A good observation. In almost every other context, we've started counting at 0 and 1 instead of 1 and 2. It turns out there's something else in location 0 when it comes back from re.search related to the string itself. So according to the documentation of this function only, 1 is the first set of parentheses, and 2 is the second set, and onward from there. Just a different convention here. Other questions?
What if we write nothing, like white space, comma, white space? How we check true of condition?
Before I answer directly, let me just run this and make sure I've not broken anything further. Let me run Python of format.py. Let me type in David space Malin the right way. Let me run it once more. Let me type in Malin, comma, David the wrong way that we're fixing, and we're still good. But I think it will still break. Let me run it a third time with Malin, comma, David with no space. And now it's still broken. Why? Because I'm still looking for comma space. Now, how can I fix that? One way I could do that is to add a question mark here, which again is 0 or more of the thing before. So if I have a space and then a question mark literally, no need for any parentheses, then I can literally tolerate both Malin, comma, space David or Malin, comma, David. So let's try again. Before this did not work. Let's do Malin, comma, David with no space. Now it does actually work. So we can tolerate different amounts of white space if I am a little more precise with my formula. Let me go ahead and try once more. Let me very weirdly, but possibly, hit the spacebar a few too many times. So now they're really separated. This again is not going to work quite right because it's going to consume all of that white space. So now I might want to strip left and right any of the leading white space on the result. Or what I could do here is say this. Instead of 0 or 1, I could use a star here. So space star. And now if I run this once more with Malin, comma, space, 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 David, enter, now we've cleaned up things further. So you can imagine, depending on how messy the data is that you're cleaning up, your regular expressions might need to get more and more sophisticated. It really depends on just how many problems we want to solve at once. Well, allow me to propose that we forge ahead further just to clean this up even more so using a feature that's actually relatively new to Python itself. It is very common when using regular expressions to do exactly what I've done here, to call a function like re.search with capturing parentheses inside such that you get back a return value that I'm calling matches. You could call it something else, but I'm calling it by default matches. And then notice on the next line, I'm saying if matches. Wouldn't it be nice if I could just tighten things up further and do these all on the same line? Well, you can sort of. Let me go ahead and do this. Let me get rid of this if. And let me just try to say something like this. If matches equals re-search and then colon. So combining my if condition into just one line instead of those two. In C or C++ or Java, you would actually do something like this, surrounding the whole thing with parentheses, sometimes double sets to suppress any warnings, if you want to do two things at once. If you want to not only assign the return value of re.search to a variable called matches, but you want to subsequently ask a Boolean question. Is this effectively true or false? That's what I was doing a moment ago. Let me undo this. A moment ago, I was getting back the return value and assigning it to matches. And then I was asking the question. Well, it turns out this need to have two lines of code presumably rubbed people wrong for too long in Python. And so you can now combine these two kinds of lines into one, but you need a new operator. You cannot just say if matches equals research and then a colon at the end. You instead need to do this. You need to do colon equals if and only if you want to assign something from right to left, and you want to ask an if or an elif question on the same line. This is affectionately known, as you can see here, as the walrus operator. And it's new to Python in recent years. And it both allows you to assign a value, as I'm doing, from right to left, and ask a Boolean question about it, like I'm doing with the if or equivalently elif. Does anyone know why this is called the walrus operator? If you kind of look at it like this, perhaps, if you're familiar with walruses, it kind of sort of looks like a walrus. So a minor detail, but a relatively new feature of Python that honestly you'll probably continue to see online and in source code and in textbooks and so forth, increasingly so now that it does exist. It does not change the logic at all. If I run python of format.py and type Malin, comma, space David, it still fixes things, but it's tightened up my code just a bit more. All right, let's go ahead and look at one final problem to solve, that of extracting information now as well. So at this point, we've now validated the user's input by checking whether or not it meets a certain pattern. We've cleaned up the user's input by checking against a pattern whether it matches or not. And if it does match, we kind of reorganize some of the user's information so we can clean up their input and standardize the format in which we're storing or printing it in this case. Let's do one final example where we're very specifically extracting information in order to answer some question. So let me propose this. Let me go ahead and close format.py and create a new file called twitter.py. The goal of which is to prompt users for the URL of their Twitter profile and extract from it, infer from that URL, what is the user's username. Now, why might you want to do this? Well, one, you might want users to be able to just very easily copy and paste the URL from their own Twitter profile into your form, into your app, so that you can figure out what their username is. Or you might have a form that asks the user for their Twitter username. And because people aren't necessarily paying very close attention, some people type their username. Some people type their whole URL or something else altogether. It would be nice, now that you're a programmer, to just be more tolerant of different types of input and just take on the burden of canonicalizing, standardizing the data, but being flexible with the users. It's arguably a better user experience if you just let me copy paste or type in what I want. You clean it up. You're the programmer, not me. Lends for a better experience, perhaps. Well, let me go ahead and do this with twitter.py. Let me first go ahead and prompt the user here for a value for a variable that I'll call URL, and just ask them to input the URL of their Twitter profile. I'm going to go ahead and strip off any leading or trailing white space just in case users accidentally hit the spacebar. That's like literally the least I can do quite easily. But now let's go ahead and do this. Suppose that the user's address is the following. Let me print out what they type in, and let me clear my screen and run Python of twitter.py. I'm going to go ahead and type in, for instance, https://twitter.com/DavidJMalin, which happens to be my own Twitter username. For now, we're just going to print it back onto the screen just to make sure I've not messed up yet. OK, so I've printed back out the exact same URL, but the goal at hand is to extract the username only. Now, let me just ask perhaps a straightforward question. Logically, what do I need to do to get at the user's username?
Well, we just ignore what's before the username and then just extract the username.
Perfect. Yeah, I mean, it is as simple as that. If you know the usernames at the end, well, let's just somehow ignore everything to the beginning. Well, what's at the beginning? Well, it's a URL. So we're probably going to need to ignore an HTTPS, a :// a twitter.com, and a slash. So we just want to throw all of that away. Why? Because if it's a URL, we know by how Twitter works that the username comes at the end. So let's use that very simple idea to get at the information we want. Well, I'm going to try this a few different ways. Let me go back into my program here, and instead of just printing it out, which was just to see what's going on, let me do this. Let me create a new variable called username, and let me call url.replace. It turns out that if URL is a string or a str in Python, it again comes with multiple methods like strip and split and others as well, one of which is called replace. And replace will do just that. You pass it 2 arguments, the first of which is what do you want to replace? The second argument is what do you want to replace it with? So if I want to get rid of, as Ivan proposed, really just everything before the username, that is the Twitter URL or the beginning thereof, let's just say this. Go ahead and replace https://twitter.com/ close quote. That's what I want to replace. And comma, second argument, what do you want to replace it with? Nothing. So I'm literally going to pass in quote unquote to effectively do a find and replace. That's what the replace method does, just like you can do it in Microsoft Word or Google Docs. This is the programmer's way of doing find and replace. Now, let me go ahead and print out just the username. So I'll use an F string like this. I'll say username, : and then in curly braces, username, just to format it nicely. All right, let me go ahead and clear my screen and run Python of twitter.py, enter. URL, here we go, https://twitter.com/DavidJMalin, enter. OK, now we've made some progress. Done for the day, right? Well, what is suboptimal about this? Can anyone critique or find fault with my program? It is working now, but it's a little fragile. I bet we could contrive some scenarios where I think it works, but it doesn't.
Well, I have a few ideas actually. Well, first of all, if we don't specify HTTPS, it will broken. Secondly, if we have slash at the end, it also will be broken. If we have like question mark or something after question mark, it also won't work. So a lot of scenarios actually.
Oh my God. I mean, here we are. I was pretending to think I was done, but my God, like Alex gave us a whole laundry list of like problems. And just to recap then, what if it's not HTTPS, it's HTTP? Slightly less secure, but I should still be able to tolerate that programmatically. What if the protocol's not there? What if the user just typed twitter.com/DavidJMalin? It would be nice to tolerate that rather than show an error and make me type in the protocol why. It's not good user experience. What if it had a slash at the end of the username or a question mark? If you think about URLs you've seen on the web, there's very commonly more information, especially if it's been shared on social media. There might be HTTP parameters, so to speak, just stuff there that we don't want. There could be a www.twitter.com, which I'm also not expecting, but does work if you go to that URL too. So there's just so many things that can go wrong. And even if I come back to my contrived example as earlier, what if I run this program and say this? My username is https://twitter.com/DavidJMalin, enter. Well, that too just just didn't really work. It got rid of the actually, okay, actually that kind of worked. But the goal here is to actually get the user's username, not an English sentence describing the user's username. So I would argue that even though I just accidentally created perfectly correct English grammar, I did not extract the Twitter username correctly. I don't want words like my username is as part of my input. So how can we go about improving this and maybe chipping away at some of those problems one by one? Well, let me clear my screen here. Let me come back up to my code and let me not just replace it, but let me do something else instead. I'm going to go ahead and instead of using replace, I'm going to use another function called remove prefix. A prefix is a string or a substring that comes at the start of another. So if I remove prefix, I don't need a second argument for this function. I just need one. What prefix do you want to remove? So this will at least now fix the problem I just described of typing in like a whole sentence where the URL is there, but it's not at the beginning, it's only at the end. So here, this still is not correct, but we don't create this weird looking output that just removes the URL part of the input. My username is https://twitter.com/DavidJMalin. A moment ago, it did remove the URL and left only the David come back and maybe my username is as part of my input. So how can we go about improving this and maybe chipping away at some of those problems one by one? Well, let me clear my screen here. Let me come back up to my code and let me not just replace it, but let me do something else instead. I'm going to go ahead and instead of using replace, I'm going to use another function called remove prefix. A prefix is a string or a substring that comes at the start of another. So if I remove prefix, I don't need a second argument for this function. I just need one. What prefix do you want to remove? So this will at least now fix the problem I just described of typing in like a whole sentence where the URL is there, but it's not at the beginning, it's only at the end. So here, this still is not correct, but we don't create this weird looking output that just removes the URL part of the input. My username is https://twitter.com/DavidJMalin. A moment ago, it did remove the URL and left only only the David J. Malin. This is not perfect still, but at least now it does not weirdly remove the URL and then leave the English. It's just leaving it alone. So maybe I could handle this better, but at least it's removing it from the part of the string I might anticipate. Well, what else could we do here? Well, it turns out that like regular expressions just let us express patterns much more precisely. We could spend all day using a whole bunch of different Python functions like remove prefix or remove and strip and others and kind of make our way to the right solution. But a regular expression just allows you to more succinctly, if admittedly more cryptically, express these kinds of patterns and goals. And we've seen from parentheses, which can be used not just to group symbols together as sets, but to capture information as well, we have a very powerful tool now in our toolkit. So let me do this. Let me go ahead and start fresh here and import the RE library as before at the very top of my program. I'm still going to get the user's URL via the same line of code, but I'm now going to use another function as well. It turns out that there's not just re.search or re.match or re.fullmatch. There's also re.sub in the regular expression library, where sub here means substitute. And it takes more arguments, but they're fairly straightforward. The first argument to re.sub is the pattern, the regular expression that you want to look for. Then you have a replacement string. What do you want to replace that pattern with? And where do you want to do all that? Well, you pass in the string that you want to do the substitution on. Then there's some other arguments that I'll wave my hands at for now. Among them are those same flags and also a count, like how many times do you want to do find and replace? Do you want it to do all? Or do you want to do it just one? Or so forth. You can have further control there too, just like you would in Google Docs or Microsoft Word. Well, let me go back to my code here. And let me do this. I'm going to go ahead and call re, not search, but re.sub for substitute. I'm going to pass in the following regular expression, https://twitter.com/ and then I'm going to close my quote. And now what do I want to replace that with? Well, like before, with the simple stir replace function, I want to replace it with nothing. Just get rid of it altogether. But what string do I want to pass in to do this to? The URL from the user. And now let me go ahead and assign the return value of resub to a variable called username. So resub's purpose in life is, again, to substitute some value for some regular expression some number of times. It essentially is find and replace using regular expressions. And it returns to you the resulting string once you've done all those substitutions. So now the very last line of my code can be the same as before, print, and I'll use an F string, username, colon, and then in curly braces, username. So I can print out literally just that. All right, let's try this and see what happens. I'll clear my terminal window, run python of twitter.py, and here we go. https://twitter.com/davidjmalin. Cross my fingers and hit enter. OK, now we're in business. But it is still a little fragile. And so let me ask the group, what problem should I now further chip away at? They've been said before, but let's be clear. What's one or more problems that still remain?
The protocols and the domain prefixes po.
Good, the protocol, so HTTP versus HTTPS. Maybe the subdomain, www, should it be there or not? And there's a few other mistakes here too. Let me actually stay with the group. What are some other shortcomings of this current solution?
If we use a phrase like you do before, we are going to have the same problem because it's not taking account in the first part of the text example.
Good. I might still allow for like some words, some English to the left of the URL because I didn't use like my caret symbol. So I'll fix that. And any final observations on shortcomings here?
It could be a HTTP, or there could be like less than 2 slashes.
OK, so it could be HTTP, and I think that was mentioned too in terms of protocol. There could be fewer than 2 slashes. That I'm not going to worry about. If the user gives me 1 slash instead of 2, that's really user error, and I could be tolerant of it. But you know what? At that point, I'm OK yelling at them with an error message saying, please fix your input. Otherwise, we could be here all day long trying to handle all possible typos. For now, I think in the interest of usability or user experience, UX, let's at least be tolerant of all possible valid inputs or reasonable inputs, if you will. So let me go here and let me start chipping away at these here. What are some problems we can solve? Well, let me propose that we first address the issue of matching from the beginning of the string. So let me add the caret to the beginning. And let me add not a $sign at the end, though, right? Because I don't want to match all the way to the end because I want to tolerate a username there. So I think we just want the caret symbol there. There's a subtle bug that no one yet mentioned. And let me just kind of highlight it. And see if it jumps out at you now. It's a little subtle here on my screen. I've highlighted in blue a final bug here. Maybe some smiles on the screen. Yeah, can we take one hand here? Why am I highlighting the dot in twitter.com, even though it definitely should be there?
So the dot without a backslash means any character is of a new line?
Yeah, exactly. It means any character. So I could type in something like Twitter !com or Twitter anything com, and that would actually be tolerated. It's not really that bad, because why would the user do that? But if I want to be correct and I want to be able to test my own code properly, I should really get this detail right. So that's an easy fix too, but it's a common mistake. Anytime you're writing regular expressions that happen to involve special symbols, like dots in a URL or domain name, a $sign in something involving currency, remember, you might indeed need to escape it with a backslash like this here. All right, let me ask the group about the protocol specifically. HTTPS is a good thing in the world. It means secure. There is encryption being used, so generally you like to see HTTPS, but you still see people typing or copy-pasting HTTP. What would be the simplest fix here to tolerate, as has been proposed, both HTTP and HTTPS? I'm going to propose that I could do this. I could do HTTP vertical bar or HTTPS, which again means A or B, but I think I can be smarter than that. I can keep my code a little more succinct. Any recommendations here for tolerating HTTP or HTTPS?
We could try to put a question mark behind the S.
Perfect. Just use a question mark, right? Like, both of those would be viable solutions. If you want to be super explicit in your code, fine. Use parentheses and say HTTP or HTTPS so that you, the reader, your boss, your teacher, just know exactly what you're doing. But you know, if you keep taking the more verbose approach all the time, it might actually become less readable, certainly once your regular expressions get this big instead of this big. So let's save space where we can. And I would argue that this is pretty reasonable. So long as you're in the habit of reading regular expressions and know that question mark does not mean a literal question mark, but it means 0 or 1 of the thing before, I think we've effectively made the S optional here. Now, what else can I do? Well, suppose we want to tolerate the www dot, which may or may not be there, but it will work if you go to a browser. I could do this, www dot, wait, I want a backslash there, so I don't repeat the same mistake as before, but this is no good either because I want to tolerate www being there or not being there. And now I've just required that it be there, but I think I can take the same approach. Any recommendations? How do I make the www dot optional, just to hammer this home?
We can like group, make a square and question mark.
Perfect. So question mark is the short answer again, but we have to be a little smarter this time. As Maria's noted, we need parentheses now, because if I just put a question mark after the dot, that just means the dot is optional. And that's wrong, because we don't want the user to type in www.twitter. We want the dot to be there, or just not at all with no www. So we need to group this whole thing together. Put a parenthesis there, and then a parenthesis not after the third W, after the dot, so that that whole thing is either there or it's not there. And what else could we still do here? You know, there's going to be one other thing we should tolerate, and it's been said before, and I'll pluck this one off. What about the protocol? Like, what if the user just doesn't type or doesn't copy-paste the HTTP : or an HTTPS : right? Honestly, you and I are not in the habit, generally, of even typing the protocol anymore nowadays. You just let the browser figure it out for you and automatically add it instead. So this one's going to look like more of a mouthful, but if I want this whole thing here in blue to be optional, it's actually the same solution as Maria offered a moment ago. I'm going to go ahead and put a parenthesis over here and a parenthesis after the 2 slashes and then a question mark, so as to make that whole thing optional as well. And this is OK. It's totally fine to make this whole thing optional, or inside of it, this little thing, just the S, optional as well. So long as I'm applying the same principles again and again, either on a small scale or a bigger scale, it's totally fine to nest one of these inside of the other. Questions now on any of these refinements to this parsing, this analyzing of Twitter?
What if we put a vertical bar besides this www.
What if we use a vertical bar there? So we could do something like that too. We could do something like this. Instead of the question mark, I could do www dot or nothing and just leave that in the parentheses. That too would be fine. I personally tend not to like that because it's a little less obvious to me. Wait a minute, is that deliberate, or did I forget to finish my thought by putting something after the vertical bar? But that too would be allowed there as well, if that's what you mean. Other questions on where we left things here, where we made the protocol optional too?
What would happen if we have parentheses and then inside we have another parenthesis and another parenthesis? Would it interfere with each other?
If you have parentheses inside of parentheses, that too is totally fine. And indeed, that should be one of the reassuring lessons today. As complicated as each of these regular expressions has admittedly gotten, I'm just applying the exact same principles and the exact same syntax again and again. So it's totally fine to have parentheses inside of parentheses if they're each solving different problems. And in fact, the lesson I would really emphasize the most today is that you will not be happy if you try to write out a whole complicated regular expression all at once. Like if you're anything like me, you will fail and you will have trouble finding the mistake because, my God, look at these things. They are, even to me all these years later, cryptic. The better way, I would argue, whether you're new to programming or as old to it as I am, is to just take these baby steps, these incremental steps where you do something simple, you make sure it works. You add one more feature, make sure it works. Add one more feature, make sure it works. And hopefully by the end, because you've done each of those steps one at a time, the whole thing will make sense to you, but you'll also have gotten each of those steps correct at each turn. So please do avoid the inclination to try to come up with long, sophisticated regular expressions all at once, because it's just not a good use of a time if you then stare at it trying to find a mistake that you could have caught if you did things more incrementally instead. All right, there still remains arguably at least one problem with this solution, in that even though I'm calling re.sub to substitute the URL with nothing, quote unquote, I then, on my final line of code, line 6, am just blindly assuming that it all worked. And I'm going to go ahead and print out the username. But what if the user, if I clear my screen here and run python of twitter.py, doesn't even type a Twitter URL? What if they do something like https://www.google.com/ like completely unrelatedly, for whatever reason, enter? That is not their Twitter username. So we need to have some conditional logic, I would argue, so that for this program's sake, we're only printing out, or in a back-end system, we're only saving into our database or a CSV file the username if we actually matched the proper pattern. So rather than use re.sub, which is useful for cleaning up data, as we've done here to get rid of something we don't want there, why don't we go back to re.search, where we began today, and use it to solve the same problem, but in a way that's conditional, whereby I can confidently say yes or no at the end of my program. Here's the username, or here it is not. So let me go ahead now, and I'll clear my terminal window here. I'm going to keep most of I'm going to keep the first two lines the same, where I import re and I get the URL from the user. But this time, let's do this. Let's this time search for, using re.search instead of re.sub, the following. I'm going to start matching at the beginning of the URL of the string, https, question mark to make the s optional, ://. Then I'm going to make my www optional by putting that in question marks there. Then a twitter.com with a literal dot there, so I'll stay ahead of that issue too. Then a slash, and then, well, this is where David J. Malin is supposed to go. How do I detect this? Well, I think I'll just tolerate anything at the end of the URL here. All right, $sign at the very end, close quote. For the moment, I'm going to stipulate that we're not going to worry about question marks at the end or hashes, like for fragment IDs and URLs. We're going to assume for simplicity now that the end close anything at the end of the URL. Match for, using re.search instead of re.sub, the following. I'm going to start matching at the beginning of the URL of the string, https, question mark to make the s optional, : //. Then I'm going to make my www optional by putting that in question marks there. Then a twitter.com with a literal dot there, so I'll stay ahead of that issue too. Then a slash, and then, well, this is where David J. Malin is supposed to go. How do I detect this? Well, I think I'll just tolerate anything at the end of the URL here. All right, $sign at the very end, close quote. For the moment, I'm going to stipulate that we're not going to worry about question marks at the end or hashes, like for fragment IDs and URLs. We're going to assume for simplicity now that the URL just ends with the username alone. Now, what am I going to do? Well, I want to search for this URL specifically, and I'm going to ignore case. So re.ignore case, applying that same lesson learned from before. re.search, recall, will return to you the matches you've captured. Well, what do I want to capture? Well, I want to capture everything to the right of the twitter.com URL here. So let me surround what should be the user's username with parentheses, not for making them optional, but to say capture this set of characters. Now, re.searchRecall returns an answer. Matches will be my variable name again, but I could call it anything I want. And then I can do this. If matches, now I know I can do this. Let's print out the format string username colon, and then what do I want to print out? Well, I think I want to print out matches.group1 for my matched username. All right, so what am I doing just to recap? Line 1, I'm importing the library. Line 2, I'm getting the URL from the user, so nothing new there. Line 5, I'm searching the user's URL, as indicated here as the second argument, for this regular expression, this pattern. I have surrounded the dot plus with parentheses so that they are captured ultimately. So I can extract in this final scenario the user's username. If I indeed got a match, and matches is none, it is actually containing some match, then and only then print out username. In this way, let me try this now. If I run python of twitter.py and type in https://www.google.com/, now nothing gets printed. So I've at least solved the mistake we just saw where I was just assuming that my code worked. Now I'm making sure that I have searched for and found the Twitter URL prefix. All right, well, let's run this for real now. Python of twitter.py, https://twitter.com/DavidJMalin. But note, I could use HTTP. I could use www. I'm just going to go ahead here and hit enter. Huh. None. What has gone wrong? This one's a bit more subtle. But why does matches.group1 contain nothing? Wait a minute. Maybe I did this wrong. Maybe do we need the www? Let me run it again. So here we go. https:// let's add it. www.twitter.com/DavidJMalin. All right. Enter. Ho ho ho. What is going on?
You have to say it's group 2.
I have to say group 2. Well, wait, oh, right, because we had the subdomain was optional, and to make it optional, I needed to use parentheses here, and so I then said 0 or 1. Okay, so that means that actually I'm unintentionally, but by design, capturing the www dot, or none of it if it wasn't there before, but I have a second match over here because I have a second set of parentheses. So I think, yep, let me change matches group 1 to matches group 2, and let's rerun this. Python of twitter.py, https://www.twitter, let's do this, twitter.com/DavidJMalin, enter, and now we've got access to the username. Let me go ahead and tighten it up a little bit further. If you like our new friend, it's hard not to like, if we like our old friend, the walrus operator, let's go ahead and add this just to tighten things up. Let me go back to VS Code here, and let me get rid of the unnecessary condition there and combine it up here. If matches equals that, but let's change the single assignment operator to the walrus operator. Now I've tightened things up further, but I bet there might be another solution here. And indeed, it turns out that we can come back to this final set of syntax. Recall that when we introduced these parentheses, we did it so that we could do A or B, for instance, with the vertical bar, though you can even combine more than just one bar. We used the group to combine ideas like the www dot, and then there's this admittedly weird syntax at the bottom here, up until now not used. There is a non-capturing version of parentheses if you want to use parentheses logically, because you need to, but you don't want to bother capturing the result. And this would arguably be a better solution here because, yes, if I go back to VS Code, I do need to surround the www dot with parentheses, at least as I've written my regex here, because I wanted to put the question mark after it. But I don't need the www dot coming back. In fact, let's only extract the data we care about just so there's no confusion down the road for me or my colleagues or my teachers. So what could I do? Well, the syntax per this slide is to use a question mark and a colon immediately after the open parenthesis. It looks weird, admittedly. Those of you who have prior programming experience might recognize the syntax from ternary operators, doing an if-else all in one line. A question mark colon at the beginning of that parenthetical means, yes, I'm using parentheses to group these things together, but no, you do not need to capture them instead. So I can change my code back now to matches.group1. I'll clear my screen here, run python of twitter.py. I'll again run here https://twitter.com/davidjmalin with or without the www. And now I indeed get back that username. Any questions then on these final techniques?
So first of all, could we move the caret right at the beginning of Twitter and then just start reading from there and then get rid of everything else before that, the kind of WW issues that we had? And then my second question is, how would we use kind of, I guess, either a list or a dictionary to sort the .com kind of thing, because we have .co.uk and that kind of stuff. How would we bring that into the RE function?
A good question, but no. If I move the caret before twitter.com and throw away the protocol and the www, then the user is going to have to type in literally twitter.com/username. They can't even type in that other stuff, so that would be a regression, a step back. As for the .com and the .org and .edu and so forth, the short answer is there's many different solutions here. If I wanted to be stringent about .com, and suppose that Twitter probably owns multiple domain names, even though they tend to use just this one. Suppose they have something like .org as well. You could use more parentheses here and do something like this, com or org. I'd probably want to go in and add a question mark colon to make it non-capturing, because I don't care which it is. I just want to tolerate both. Alternatively, we could capture that. We could do something like this, where we do +, so as to actually capture that. And then we could do something like this. If matches.group1 now equals com, then we could support this. So you could imagine factoring out the logic just by extracting the top-level domain, or TLD, and then just using Python code, maybe a list, maybe a dictionary, to validate elsewhere outside of the regex if it's in fact what you expect. For now, though, we kept things simple. We focused only on the .com in this case. Let's make one final change to this program so that we're being a little more specific with the definition of a Twitter username. It turns out that we're being a little too generous over here, whereby we're accepting one or more of any character. I checked the documentation for Twitter, and Twitter only supports letters of the alphabet, A through Z, numbers 0 through 9, or underscore. So not just dot, which is literally anything. So let me go ahead and be more precise here. At the end of my string, let me go ahead and say this set of symbols in square brackets. I'm going to go ahead and say A through Z, 0 through 9, and an underscore, because again, those are the only valid symbols. I don't need to bother with an uppercase A or a lowercase z, because we're using re.ignore case over here. But I want to make sure now that I tolerate not only one or more of these symbols here, but also maybe some other stuff at the end of the URL. I'm now going to be OK with there being a slash or a question mark or a hash at the end of the URL, all of which are valid symbols in a URL, but I know from the Twitter's documentation are not part of the username. All right, now I'm going to go ahead and run python of twitter.py one final time, typing in https://twitter.com/DavidJMalin. Maybe with, maybe without a trailing slash, but hopefully with my biggest fingers crossed here, I'm going to go ahead now and hit enter. And thankfully, my username is indeed David J. Malin. So what more is there in the world of regular expressions and this own library? Not just re.search and also re.sub. There's other functions too. There's re.split, via which you can split a string, not using a specific character or characters like a comma and a space, but multiple characters as well. And there's even functions like re.findAll, which can allow you to search for multiple copies of the same pattern in different places in a string, so that you can perhaps manipulate more than just one. So at the end of the day now, you've really learned a whole other language, like that of regular expressions, and we've used them in Python, but these regular expressions actually exist in so many languages too, among them JavaScript and Java and Ruby and more. So with this new language, even though it's admittedly cryptic when you use it for the first time, you have this newfound ability to express these patterns that, again, you can use to validate data, to clean up data, or even extract data and from any data set you might have in mind. That's it for this week. We will see you next time.
Well, hello one and all, and welcome to our short on patterns. We will look at how we can use regular expressions to create some pattern we expect in some data we might have. Now, we've seen how to do this with emails, but one other kind of data we might be able to validate using a pattern is something called a hexadecimal color code. So it turns out that color regular expression allow me to might have. Now, we've seen how to do this with emails, but one other kind of data we might be able to validate using a pattern is something called a hexadecimal color code. So it turns out that colors like this shade over here have to them a certain assigned hexadecimal color code, a way of representing this color but in a computer's memory. So this particular color has this particular code, the hash symbol 0076BA. This corresponds to this particular shade of blue. It turns out there's a pattern to this pattern you see over here. In fact, they always will begin with this hash symbol, and they'll be followed by 6 characters, which range from 0 to 9, or A to F, upper or lowercase. And it turns out there's also a bit of a structure to them too. The very first two characters after, let's say, the hash symbol, well, that defines how much red is in this color on a scale of 0, 0 to FF, the highest. There's also this second set of two characters, in this case 7, 6, which corresponds to the amount of green in the color. And then the final two, in this case BA, correspond to the amount of blue that's in this particular color here. Again, each of these two sets of characters ranging from 0, 0, the lowest, meaning no red, no blue, no green, or the highest being FF, meaning all the red, all the green, all the blue, for instance. Now let's look at a few other examples here. So here, as I said, this is entirely red. The reddest red you can get, it is hash symbol FF0000, entirely red with no other colors involved. This here is green, 00, FF00, and this, let's say, is blue. The bluest blue you can get, at least on the web, using these particular color codes, 0000, FF. Now, we can combine these colors too and get both black and white. So black, let's say, or actually white, white being the, all the colors combined is FF, 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 and black being the absence of color, well, that will be 00, 00, 00, 00. So this was our brief intro to these hexadecimal color codes. Let's go and see how we can create a pattern to validate codes like these. So I have over here a program called code.py, and the goal again is to validate hexadecimal color codes I might enter into this program. So up top, I've imported this module called RE, which stands for regular expressions. I'm going to use regular expressions in my code here. I then have a function called main, which asks the user for some input. It specifically asks them to enter a hexadecimal color code, and I store that result, what the user typed in this variable named code. But let's see how we could try to validate the input the user gives us using some kind of pattern. Well, the first thing to do might be to define the pattern we're looking for in this user's given code to say this is a valid hexadecimal color code. So I could maybe make for myself here a variable called pattern. And because this pattern is a regular expression, I'll want to prefix it with this R character here, which means I'm going to create a raw string. Typical escape characters like \n, for instance, won't be interpreted as \n, the new line character. They'll instead literally be interpreted as \, and then n. So this helps us here with regular expressions and the special syntax that those expressions have. I'll leave this blank here. Let's continue on. Let's say I want to search this particular code the user has given me for this pattern. Well, thankfully, the RE module comes with a function called search, and I can access it using re.search. Now, the first argument to search is the pattern I might expect to find in the text that I am given, let's say, from the user here. So I'll type pattern as the first argument to search. I'll then type, in this case, the string I want to search for this pattern within. So I'll type code here, just like this. And it turns out that re.search returns to me something called a match object, which I'll store conveniently in a variable called match. Now, this only happens if search actually finds the pattern I'm looking for in the given input. So let's go ahead and maybe check this out. I'll say if match, that is, if I actually find a match, well, I'll print something like this. I'll print valid. And just to be sure here, I might also try to have this match object show me what exactly it matched in this given input to search through. So I could get access to that saying maybe matched with, and then I can use match.group, this function here that will show me exactly what search found as a match given this pattern. So we'll see that in action in a little bit. Now, otherwise, if we didn't find a match, I might print something a little more simple, just like this, invalid. So this is our program, and a lot of it hinges on setting up this pattern to behave as we might expect. Well, this pattern, as we said before, will be a regular expression. And One thing we can maybe start with is the very easiest part of these hexadecimal color codes is that they all begin with this hash symbol. In fact, if we go back to some of these slides here, we'll see that these will be our rules for what to look for. It should begin with this hash symbol and be composed of 6 characters after the hash symbol, 0 through 9 and A through F, upper or lowercase. So let's begin with just this first part here. It should begin with this hash symbol. So if I go back now to my code, I could type simply this hash symbol. And this is my very simple pattern. re.search will look through the entirety of the code the user has entered, and if it finds this hash symbol anywhere in that code, it will return to me a match object and say, yes, I did find a match for this particular pattern inside the user's input. So let's try it. I'll run Python of code.py, and I'll type in, let's do a valid one. Let's say hashtag A. Don't quite know what color that is, but probably some shade of gray, given we have all the various red, green, and blues aligning in the same level here. I'll hit enter, and I'll see valid, and also matched with this hash symbol. So it seems like the reason we said this code was valid is that re.search found that hash symbol inside of this text here. But of course, I can do something like this. I could say python code.py, hashtag, let's do G, let's do I, and K. Like, this is not a valid hexadecimal color code, but according to our pattern, it is, because it sees, in this case, that hash symbol. So we need to improve this. And we can do so by using other features of regular expressions. One of them is going to be called a character set. And a character set it begins with these square brackets here, one opening and one closing. Now within these square brackets, I could include all the characters that I could possibly match after, let's say, this hash symbol. So if we go back to our slides again, we said that it should begin with a hash symbol, which we already have in our pattern. But then we expect 6 characters in the range of 0 through 9 and A through F, upper or lowercase. So let's begin, let's say, with these actual letters here. I'll go A, B, C, D, E, F to say we could match any of these individually, either lowercase a, lowercase b, C, D, E, F. We also want to take in the capital A, B, C, D, E, F, and then anything between 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So this is our character set. After we find, let's say, the hash symbol, we should expect to find any character in this set. So let's try this out. I'll go ahead and run Python of code.py, and recall we gave, I think it was hashtag GGIIKK, just random letters I made up. If I hit enter now, we'll see invalid. Now why do you think that is? Well, re.search is looking for a hashtag, which it finds, of course, but then immediately after the hashtag, we want to find a character in this character set, lowercase a through F, capital A through F, or 0 through 9. And it seems like we don't find that here. We have hashtag G, which is not in this character set. So let's go ahead and try this one. I'll try python of code.py, and let's go ahead and do the valid color from before, hashtag A, hit enter, and we'll see that this is valid, but perhaps not, again, for the right reason. I see matched with hashtag A, which is an improvement, but I think I could still do this. I could still do hashtag A, and then GGGG, which is not a valid color code, and this, I think, will still be valid. So our problem here seems to be that we're expecting the right range of characters for the first character we see after the hash, but not for all of the 6 after, let's say we have this hash symbol here. So how could we fix that? Well, we can use what's called a quantifier. And I can access a quantifier using these curly braces here. So this ensures whatever number I put in here, like 6, this means that for this particular character set, whatever character or character set precedes this quantifier, I should expect that number of them, in this case exactly. So I'll expect 6 of these particular characters inside of this set here. Let's try this out. I'll get a Python of code.py. And I think I'll demonstrate now that hashtag A, G, 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 this is not going to work for us. I'll hit enter, and I'll see that is invalid. Let's try this one now, Python of code.py. I'll do hashtag A, and that seems to be valid now for the right reason. We matched with the entire thing. All of these, in this case, fall into this range of valid characters. But I think there's still one more thing to go and improve here. Let's try this. I'll do Python of code.py. Let's get a little bit tricky. I'll do hashtag AA, and then something like, why don't we just do a 0 at the end. Now this is not a valid color code. This is more than 7 characters. I'll hit enter here, and it's still valid. Now, this might be confusing, because I did say earlier that this quantifier here ensures that we get exactly 6 of the characters in this character set. And, well, it seems like we've done that. Like I have here in this code hashtag, hash symbol here, and then A, that's certainly 6 of them. And so I seem to have found a match inside of this longer string. And it's a little more clear. I could even do this. Python of code.py. The code is hash symbol A. Well, this is valid, even though I typed in the code is, which I don't want to include in a valid hexadecimal color code. So one thing I can use here is called an anchor. If I want to say that my pattern should start at the beginning of the string, I can do so by adding a caret here. So this will say that when I search for this pattern, this hash symbol must be the very first character that I see in the input text. So this would no longer be valid under this caret symbol here, this anchor. Let me try it again. I'll do Python of code.py. I'll say the code is hash symbol A, hit enter. That now is invalid because our very first character in this input is not the hash symbol. Now similarly, we can do an anchor at the end, which looks like a $sign, and that means that the last characters we expect should be these 6 in this range here. So this will exclude things like the hash symbol AA0, because that is more than, in this case, 6. The last character we're matching is not within the 6 we expect here. So I'll run Python of code.py, and I'll type in hash symbol AA0, and that, of course, is invalid as well. So I think this pattern works pretty well for us, but there is one way to improve how we write it. I could, instead of typing all this out, use a range. I can say, conveniently, A-F to insinuate or to imply I want A, B, C, D, E, and F as valid characters. I could do the same thing for capital A to capital F, just like this, capital A dash capital F. That would give me capital A, B, C, D, E, F. And again, same thing for 0 through 9. I could do hashtag here, giving me 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, all inclusive. So this, I believe, should do the same thing for us. I'll type python of code.py, type in hash symbol AA, and this seems to be a valid color code. So we've seen here how to use these things called regular expressions and the patterns that actually implement them to validate things that have a pattern to them. These are useful beyond just these. Anything has a pattern to it, you can probably try to validate using these things called patterns and regular expressions. This then was our short on patterns, and we'll see you next time. Well, hello one and all, and welcome to our short on capture groups. Now, those of you who have made international calls might be familiar with what's called a country calling code. And I have here 3 of them up above in a dictionary called locations. I have one, +1, which often involves numbers from the United States and Canada. I have one +62, which often involves numbers from Indonesia, and one +505 that involves numbers from Nicaragua. And I have down below here in main a program that in this case validates phone numbers internationally. So I have here a pattern that I'm going to look for within each of these phone numbers I might enter into my program down below on line 7. In this case, notice what I'm expecting. I'm expecting the literal actual character plus here. I've escaped it with this backslash because plus has other meanings within regular expressions. I'm now expecting any kind of number, in this case, 0 through 9, between 1 and 3 times. So notice here, the country code for the US and Canada, that's +1, so only one number here. For Indonesia, it's 2, 62, and for Nicaragua, it's 3, 505. So between, in this case, 1 and 3 numbers following some plus. Thereafter, there will hopefully be a space for this a valid number, and then there will be exactly 3 numbers, a dash, again exactly 3 numbers, followed by a dash again, and then exactly 4 numbers. So this is the pattern we are looking for, and down below on lines 9 through 13, well, this is the code doing that work for us. We've stored within number the user's phone number that they have entered, and we're going to check using re.search if we found a match for our pattern within the number string. If we do have a match as returned to us, we'll print valid. If we don't, we'll print invalid. Let me go ahead down below here. Let me type main to ensure I call main when I run this program. And I'll go ahead and run python of groups.py, and if I hit enter now, I should be able to enter a number. Well, I'll test one here, +1, and I'll type in 617,495,1000. I'll hit enter here, and we'll see that that is valid. Maybe I'll try it too for Indonesia. I'll do +62, and I'll enter in my phone number again, and I'll hit enter, and we'll see that's valid as well. And just for good measure, I'll test Nicaragua. I'll do +505, and I'll type in this number, and we'll see that is valid as well. So it seems like our pattern is working, but there's more we could do with this program, I think, thanks to this feature called a capture group. Well, maybe what I want to do is not just share if this number is valid or invalid, but maybe tell somebody from what country, in this case, this number is calling from. You can think of your phone. When it receives some call from an unknown number, it might at least tell you the location or the area that number is calling from. What if we write the same thing here, where people call us internationally, and we show the user, in this case, what country they are calling from? Well, in this case, we don't want to just test to see if we find the pattern within our phone numbers here. We also want to extract some portion of it. In this case, the very first portion, the country calling code, +505 for Nicaragua, +62 for Indonesia, or +1 for the US and Canada. But we run into a problem here if we were to use maybe simple string manipulation. If I entered in some number and was trying to extract, in this case, the country calling code, well, I wouldn't immediately know whether I should extract, in this case, the first 2 characters, +1, the first 3 characters, +62, or, in this case, the first 4 characters, +505. But thankfully, I'd actually use regular expressions and capture groups to dynamically capture the portion of the content I'm looking for. Now, the way I can make a capture group is by using parentheses inside of a regular expression. So really, I want to capture or extract, in this case, the country calling code, which we said the pattern exists for right here, a literal plus sign followed by 1 to 3 numbers. Now I can encase this inside of parentheses, and this becomes my own capture group. But how could I maybe find the information I capture? Well, if I find a match here, turns out that this match object in Python comes with another one called group. If I were to do, let me do match.group, well, this would help me find all of the capture groups I've actually implemented in my regular expression and extract them from this match. Because let's say this is the first capture group we have, I could go ahead and type 1 here. Capture groups, at least in Python, in this particular case, are 1 indexed. So I'm saying here, if there is a match, go ahead and give me, in this case, the result that I found within the first capture group. I'll go ahead and store this in a variable called country code, and I could, instead of printing valid here, maybe I'll go ahead and print something like country code and see what we can find. I'll go ahead and run Python of groups.py, and I'll go ahead and do +1 followed by my phone number, hit enter, and now we'll see +1. So it seems like we extracted, in this case, the portion of our content that matched the pattern within these parentheses. I'll try it with another one here. I'll do Python of groups.py +62, and we'll see +62. So it is dynamic. It's not looking for the first 2 characters all the time, or the first 3 characters all the time. It's looking for this pattern, and when it finds it, is returning it to us as appropriate. Now, what else could we do with this? Well, country code literally is a string here. So if I wanted to, in this case, find the country somebody is calling from based on their country calling code, well, I could perhaps use country code as the key for this dictionary here. I could type locations, bracket, locations, bracket, country code, and because each of these country calling codes is a key in my dictionary, I should hopefully find, in this case, the actual location they are calling from. Let's try this out. I'll run Python of groups.py, and I'll now type, let's do +1 again, followed by the number, hit enter, and now we'll see United States and Canada. I could do this again. I could try, let's say, a +62, and number again, Indonesia. I'll now try +505, and I'll see Nicaragua. So the capture group here is doing the work of finding the portion of our content that matches some pattern we were looking for. Well, I think we've really seen a lot of what this can do for us, but there is one more feature to take a look at. Here, notice how on line 11, I am really using indexes to find the capture group I'm looking for. But a more complex regular expression might involve more than one capture group. Could involve up to, I don't know, more than one. Could 2, 3, 4, could get up to 10. However many it is, it can be helpful to have a better way to refer to these capture groups. So if this capture group has some particular meaning to it, I could actually give it a name to refer to later on within the regular expression. And the way I do this is with the following syntax. Within my capture group, after the first parenthesis, I can type $P, and then open bracket, close bracket, or in this case, less than sign, greater than sign, and then some name for this capture group. I could call this country code, just like this. So now, this pattern here and the capture group has a name I can refer to later to extract it with. Down here on line 11, I could, in this case, use 1, but now I could actually make use of country code, the name I gave for this particular capture group, and I could type in country code, just like this, which will say, find for me, in this case, the capture group that I named country code, and use that instead. Well, I'll type Python of groups.py. I'll go ahead and type +1, same number here, and now we'll see United States and Canada seems to work, but is now a little more readable, even some named something that we might later hope to capture in our programs. So this was our brief foray into capture groups, and this was our short. We'll see you next time.